sorry, thank you. A standard case does not foresee any reduction of the size, right? But if you request it as the treating surgeon, or if we recommend, in this case, you better augment, so you, yeah, so then we stay away from the wall, and then you have the space to augment it accordingly. But it's not, this is not a standard case. So the standard case is more or less patient's anatomy, including the small extensions for primary stability, gentle extraction, placement at the same time, and then that's it.
Okay, so we're going to continue. So I didn't actually prepare for these type of printer, but I went outside and I saw this printer. So I want to talk to you just a little bit. I'm sure the video, you don't need to buy this printer. I just saw it outside. So I took the YouTube video so that it's slightly different. So the principle of the printer is the same. So we talk about the SLA printer, which is stereolithography printer, and it will print from layer by layer using ray laser that run this way. So the second generation of SLA printer is called the DLP printer. And the DLP is one of the one that have outside is Bagel. It's outside. So what it does is instead of you laser shoot layer by layer, you laser in the whole layer at the same time. It's just like you project the pictures. So you project the picture each layer and it gets cured at the same time. The principle is the same, but it moves faster because it goes each layer. In the United States, there's another company called Moonray, which is a very inexpensive printer as well. And it also have the DLP feature on it. The advantage of the type of printer is instead of you printing a cast or a surgical guide for about maybe 3 to 4 hours, it will cut down to 30, 45 minutes. So these type of printer will be a lot faster. I'm just showing you the video, that's it. There you go. So you can see that the projector, so it projects each layer. So instead of laser run through, so it goes faster that way and it moves up a lot faster than the Form 2 printer. I think we can stop the video. Go to the next one. Let's see, let's go to this one. Let's see where I can find it. Just a bit. Give me just a minute, sorry. Here we go. I couldn't find a play button. Now, we're going to switch gear a little bit and talk about the intraoral scanner and what research about the intraoral scanner precision. So the CAD/CAM technology, basically you start from design, scan, design, and manufactures. We talked about it earlier this morning. And it's not unique to dentistry. You know, the automobiles and aerospace industry have been using the technology since the 80s, since the technology came out. And in the future, you probably would be like, for instance, if you want to buy shoes, and Dr. Ratsupap might wear size 12, and I might wear size number 8. Instead of the factory have to stock hundreds and thousands of sizes for everybody. So when Dr. Rat ordered things from Amazon, and they could print it right away and mail it to him. So that way they don't have to stockpile everything like no tomorrow. So in the future, the 3D printing technology is going to go into make something a lot cheaper. Now it's going to be more commercially used, and it, of course, is going to be a lot more personal use too. This is just another summary of the timeline. We talked about this already. Now let's talk a little bit about the scanner. So not all scanners create equal. And I'm not here to sell any scanner. I don't care what scanner you buy, but what you want to do is make sure that the scanner you buy have a good accuracy and precision. There's two things, that different words, accuracy and precision. Accuracy is ability to replicate whatever is scanned. You scan a tube that 10 millimeter wide, it should come up 10 millimeter wide. The second one is the precision, meaning that each time it's scanned, it can reproduce the same thing over and over. Like even if, let's say my scanner have a dimension, have inaccuracy of maybe 0.0001 millimeters. Every time it scans everything, it will have keep the same error. Because if you know the error, and the error is small, you can accommodate it using computer technology. So these two numbers, the most important for pick the scanner. The second thing is if it's reliable and if it's easy to use. And the last thing, of course, the cost, because a lot of this scanner is $20,000 plus. So it's very expensive. And once you're committed to it, you kind of have investment to that company and you get stuck with it for a long time. So these are just on the right side is the Trio scanner of the intraoral of the same patient, and that is the digital photography. So you can see that the accuracy of the scanning now is in incredible detail, and we actually did some research on this, and I will show you in the afternoon how we use the color scanner to do some research. You actually want, if it's possible, you want a color scanner because you have a lot of advantages of the color. Let's see, this one doesn't show. Okay, here we go. So if you look at the accuracy and precision, this is the iTero, the Trios, the True Definition, and the iTero. These are basically the same level of scanner. And the difference is just a tiny margin of error, the difference. This is the OmniCam, which is probably, I don't know which you guys have. Those two, these are probably the scanner you don't want because it's too high of inaccuracy and too much of error to it. Similar graph on the right side for the precision. And nowadays you can integrate. If you don't use your scanner yourself, your lab going to scan all your dye now. When you send things to the lab, even though you don't scan the patient, the lab going to scan your cast. So all of these are integrated into the laboratory technology nowadays. In the office, just to recap for some people who didn't listen this morning or didn't come this morning, these are the main things that we use. We use for restorative model, we use for vacuum form and orthodontic model, appliance, surgical guide, and educational model. We start to print the surgical, print occlusal splint and mouth guard. And actually, I went to Richmond is closest. Richmond, Virginia Commonwealth doesn't have football team. So I actually work with the UVA, with University of Virginia, and they have a not so good football team. But they have football teams, so I went and I scanned all the football team mouth and then fabricate the mouth guard for them. So they no longer use the alginate impression. We scan and they can keep the record digitally for the football players. Now we talk a little bit about the print and mill cast. So there's a study that actually recent in Journal of Dentistry, and they use the metal reference model, and they did a PVS impression, and then they use conventional impression, and they use two types of replica printing and milling, and they found that the printing and milling actually almost as good as the gypsum. But they suggest that you probably don't want to do more than 4 units. The more than 4 units still, we don't have a technology right now to do more than 4 units. And if you want to try, you want to try the mill model, not the printed model. Now, the other thing you want to consider is the issue with intraoral scanning is the curvature of the arch. for instance, this study looked at the position 1, 2, 3, 4 of the maxilla. And if you look at the color, if the color green, meaning that it perfectly align, different color in blue or red, you have too much or too little materials, or the digital component to it. This is the 3M scan, the Omni scan, the regular impression, and the Trio scan. And you can already tell from the pictures if the 3M scan is a little bit over, the Trio scan is just a little bit over, impression is basically all over the place. And then the Omni scan are not really good at all because you have red and you have blue everywhere. So in this study, still, it suggests that you can only use for 4 units, especially on the anterior. Now the problem with the anterior is because when you scan in one dimension. You take picture, which is the flat picture. Remember the photographic genesis of the three-dimensional that we talked about this morning? Basically, you do the same thing, but the computer does it for you. In the posterior segment, you only have curvature this way mainly, and a little bit this way. But in the anterior maxillary area, you have 3 or 4 curvature sometimes, and depending on the acute of the curvature here and the curve of the palate, you're going to have more problem with the intraoral scan when you use multiple unit. Now, if you go to the Formlab website and go to the implantology section of them, they actually have, we wrote the white paper for them, and this is actually me, and that is Daniel Whitley, my student. And mainly what we do now is we do about 90% of guided surgery using 3D printer. So all our guided surgery, we print the guy ourselves, 90%. 90% of use of the printer. About 5% we print our model. We don't do it as much. And about another 5% we print the model for oral surgery or perio. And the next section before lunch, I will talk a little bit about the guided surgery we do. And basically, nowadays we start from the first time we see the patient for implant, we do intraoral scan, we do a CBT scan, and then we do an implant consult with the treatment planning, and then we fabricate the guide, and we bring the patient into the surgery. We see less and less of this now, but we still see them. And especially at Virginia Commonwealth University, we don't have a graduate prosthodontic program because it would be great to send it to residents to have them figure it out. So I have to fix some of these, and sometimes, unfortunately for this case, for example, we have to take all the implant out and start over from scratch. Now, one of the reasons why we want to do guided implant surgery because we try to avoid the surgical complication. And the classic Charles Goodacre paper is we still have about 24% that hemorrhage is related and about 2% of neurosensitive disturbance. You have a small percent of mandibular fractures. So you all probably, especially a prosthodontist, you're going to see some of these happen, hopefully not the mandibular fractures. Now, this is actually one of my patients who supposed to get an implant placed in oral surgery, but the patient was from Brazil, so he decided he can go back to Brazil and then get it done a lot cheaper, like people come to Thailand. But whoever do implant for him is very lucky because he placed implant down to here in the lingual concavity here. Obviously, he didn't use CT scan, but evidently the implant ended up failing unrelated to where it placed. We may not have to remove implant, but he have the hole through all of the 4 implant in the mandibular posterior. And if the person or the patient or the person who placed implant not so lucky, they might end up in Journal of Oral Maxillofacial Surgery because you can eat the bleeding and the patient won't be able to breathe, and you're going to have to send the patient to the ER. Now, we started changing standard of care now because we used to do panoramic radiograph. When we were resident, we used a tomogram, which is not so good predictor of implant size and bone volume. If you look at one of my good friend, George Deep, who's an oral surgery, he ran the implant clinic at Virginia Commonwealth, did this study, so he used the Panorex and the CBCT, and he asked a bunch of oral surgeons to predict the size of the implants, and he compared that to the real implant that got placed. So you can see that if you have panoramic, and even these are good experienced surgeons, you can't really predict it that well because these range are so wide compared to the CBCT that you can predict the implant length and width pretty accurately. But you know, the oral surgeon is still very conservative on changing recommendation. He published this in JOMS, and he can't say that it now standard of care, even though he wanted to. So what's the problem in panoramic radiograph only? The issue number one is if you need, whether or not you need a bone graft, you won't know it. Especially you can't see the buccolingual of it. And if you're going to need a multiple backup implants because you don't know the size precisely. It's not easy to transfer the prosthetic plan to the implant placement. And it's difficult in certain cases. For example, you do immediate implant that have mental foramen, anterior loop, or the posterior mandible where the lingual concavity is. And this is the implant that I placed many years ago. And you can see that if you look at the panoramic, you're going to see the mental foramen here. You would not know that you can actually go put the implant down to here, and we're far away from the nerve. And this day, especially in a lot of schools that do a lot of implant, like Loma Linda or like Virginia Commonwealth, University of North Carolina, we routinely do a post-op CT scan. And you don't have to use the high dose like diagnostic. You can use a post-op dose, which is a lot less radiation, and it's just like you take a pan. So the bottom line to me is panoramic radiograph is not sufficient for place most of implants. So what about using CBCT for computer-aided implant planning? We're going to go step by step through it. Now, we use the same process for everything. For model for fixed, for ortho, for implant, for occlusal splint, and for dentures. We're going to scan, design, print, and prepare. The difference would be what kind of scan you're going to use, who can decide what software you're going to use to design, what kind of printer you're going to use, and that will dictate how you finish your product. I'm going to skip the cost part. Now the workflow. This is example of the tree-shaped implant studio workflow. So what I like about this is you're going to scan first, and then you're going to do diagnostic setup because it makes you do diagnostic setup. Once you do diagnostic setup, you put in articular, everything looks good, then the software would merge this automatically with the CBCT. So it would use the tip of the cusp to merge it, and then you go to the design, and then you export it, and then you print it. We're going to go through this step by step here. So in all of the planning software, when they send it to you, they're going to send you a recipe. And I see if you can read, you can do it, right? So it's going to give you what kind of implant you're going to use, what is the drill length, what step of the drill, and what is the last drill, the first and last drill that you're going to use. And it can be very precise that you can see, you can determine how far away your nerve is. If you look carefully here, you see this hollow part of the implant. Is Dr. Rajapart talking about that we have to be whatever, how many millimeter between the implant. So in the tree-shaped software, you're going to have 1.5 millimeter on the proximal side of the implant, and you can have 2 millimeter on the bottom implant because most of the drill that we use are about 1.5, 2 millimeter longer. So you have like a safety zone. So in all software, and this, I'm just use this to set example. Once you get the product, once you design the guide, you're gonna have to figure out how the guide will print it. So the preform is just the free software of Formlab that you can use. This is just give you example of it. So what you want is, if you do a surgical guide, you're gonna want all of you, so you're gonna print from the bottom. This is actually flip upside down. So you can print from here up, actually the top down, right? So you don't want the integral surface that's gonna sit on the teeth close to the platform. Because once you put it close to the platform, you're gonna have to have a resin flow into it. And this resin tag here is called the support. And it will create a flow of the resin. And I think we have some video that could show you. Now, if you do the Invisalign retainer, you're gonna want to do similar thing. If you want less support, meaning you want less support, you want to raise this up like this, but it's gonna take longer for you to print. Okay, so if you put it more like this, you're gonna have more support to have to trim. Now, if you oriented your guide up this way, you also have more polymerization shrinkage because you have more layer. If you line up this way, you have a little less polymerization shrinkage. So that might be something to consider when you print. Yes, Dr. Rudd. Oh, it's a good question. So he asked about if you have if you print from the lower foot, light it up this way, right? So light and accuracy at the bottom and top would be the same. The only difference is the shrinkage would be this way. The shrinkage would be opposite of where you oriented. So if you oriented it this way, the shrinkage would be this way. If you oriented it this way, the shrinkage would be this way. So be less. So you want to orient it this way to have less shrinkage than this way. Correct, but you have a trade-off with you have more tack to clean up. Now after you, this is just to show you the software automatically, and all of the company have the same kind of thing. You pick the orientation of it, and it automatically creates support. You have to go back in there and edit them. And this is important because nobody gonna want to do this yourself, but you're gonna have to train your assistant to do it. The person who did it for me is the rising fourth-year dental student. They are actually really good. He's one guy doing everything. He printed probably 200 guides last year. So, and you can print multiple of these. But this one, for instance, gonna take about 6 to 8 hours. It take a long time. That might be something you might want to consider, the DLP printer, because if this for DLP printer, you can print this in probably 45 minutes. So this is what to show you that you also want to make sure that your support is not interfering with where you're gonna put the guide tube in. Because the guide tube gonna go into this, you don't want the support to be in the guide tube. So once you're happy with the position and where the support is, you can just click and it's gonna print it out. You can probably print it out from remotely. Now, this is in the white paper. This is actually our case, my case and Daniel's case. One is print out for the dental SG resin or the next dent resin, it can appear amber. So this resin is not completely polymerized. So you have to rinse it in the alcohol, isopropyl, dry it really well. Then you light cure it. And in the companies sell you a set of about $1,000 or something for dry and light cure. You can probably order the stuff from eBay. In the United States, they order stuff. Those nail polish curing unit, like $90. Do the same thing. And then in this resin, it change color to red, and then you trim off the support, you finish it, and you put the guide tube in. You can also trim this at this state. The advantage of trim the support at this state is that it's easier to trim. It's a little softer. The issue with it is you want to make sure that you have enough bulk of it, because if you don't have enough bulk, when you light cure it, it will shrink. And sometimes your guy would not fit at all. My recommendation is make sure that the buccolingual width of the guy is far enough, for instance, this area. You want this to be close to 10 millimeter if you can on both sides of these. If you have less than 10 millimeter, it will shrink. Yes? Correct. So Dr. Rad was asking, if you cut at the soft state, it's slightly soft, the pressure from this could distort it. Oral surgeons are the worst people who do this. Don't let them touch your material, because I have a lot of oral surgery residents who want to do everything themselves. And they're like, Dr. Bencher, my guy doesn't fit. And I said, just let the D2 dental student do it, because they are more careful. And they're not rushed to think, because if you cut this too hard, it's just going to distort it. So it's better for oral surgeon to kill completely and glue the tube in later. This is when it come out after you print. You can see this all amber color, and it's upside down. And remember that the part is actually hold it with vacuum. So you want to put this tiny little the sharp instrument in there that come with the printer usually, and you twist it to break the seal, and it will fall out. And this is just the tube. You want to do 2 alcohol bath, dry really well. Make sure you leave it to dry before you cure it. If you don't do that, you're going to have the unpolymerized resin on inside of the guy, and it won't fit to the teeth. The Form 2 have the auto cleaning and washing, which I don't really recommend them. I found that actually, if you put those in water bath, that like ultrasonic shaker, it actually clean out a little bit better than that, and actually better than their commercially that you have to pay $1,000 for it. Now, after you cure, it turned to be an like orange and red color. So that means this is completely polymerized. And now you can go to the next step, which is actually finish and polish. Me, I don't care about how nice my surgical guy is, because you just only use for a few minutes. And if you polish too much, you might break it or do something weird. So I don't need this. But if you want to polish, you can with the pumice and the sandpaper. So after it polymerized, then you autoclave it. So once you autoclave it, it's going to turn a little bit opaque white. So you know that the resin is ready to go, and it's biocompatible for using surgery. Oh, wrong way. I don't know which way I go. Let's see. Here you go. So for a long time, people don't do it because it's so expensive and it have a difficult learning curve. But I have proved to you that, you know, dental student can do it. Anybody can do it. Your lab technician probably to be, or dental assistant, probably be the best person who do this for you. We talked about this already. If you're interested, you can go to Formlab. I wrote a white paper with Daniel Whitley, and you can go in there. You have to register, and they send you all of the information of how to do it. And I don't get paid for this company at all. We just kind of help them out. And you can get the paper to their website. We've been doing quite a lot of fixed partial dentures and occlusal guard, and I don't have time to talk about it today, but maybe next time. It actually working really well for zirconia and occlusal guard. And we do a lot of, because I work a lot with oral surgery, so we print a lot of mandible out for them, usually for reconstruction. And you can print out your whole head if you wanted to. You just have to take your time to segment it because unfortunately most printers are not big enough for you to print whole head at one time. So you want to section it in, I usually section it the maxilla right here and part of cranium, the top part, and then the mandible. There are multiple software you can use. And you can print surgical guide with it. This one we just did just for fun. Okay. So this is the first case that ever done in office 3D printing for surgical guide, and it's actually in the Form Lab white paper. So the patient, actually Daniel patient, and she missing number 22. No, not number 12. I have to think about it just a minute. Number 12, because in the United States, this is number 7. Number 12, and then we plan using Blue Sky Bio software. So if you don't want to pay for the software at all, you can go to Blue Sky Bio, and they give you the free software for implant planning. And you just have to pay for the export fee for the STL file, and you have to pay for that too. And actually, the Blue Sky Bio tube are the same as Roe tube. ROE versus Roe Lab is a company for making surgical tube. So you can buy from Roe, you can buy from Blue Sky Bio, but you can download it. You can download it. There's a Mac version, there's a Windows version, and you can actually, it's not as easy to use as 3Shapes, but it's, you know, it's free. So we plan it. In this case, we're going to plan to use the small diameter Zimmer 3.1. And we make the guide. And the surgery is very simple because it's just one drill. Because it's small diameter, we just use one drill. We check. So every time you use a surgical guide, don't trust it completely. Because the most important place is the depth of your angulation, usually okay. But the depth sometimes can change a little bit. So you want to make sure that you put the drill in there and measure the depth one more time and make sure that you don't over or under drill, usually under drilled it. And these are the Zimmer 3.1. You place the implant. And then I just make the patient a small custom healing abutment. The patient already wear a Holly retainer for ortho. There's no need for us to fabricate the provisional. And we did a post-op CBCT. And I don't think you can do much better than that, but the real deal is if we accurate enough for the planning. So you can see here the green one is the placement position, and the red one is the planning position. We basically off by tiny 2 degrees. So, you know, unless you are Dr. Rat Supap, I don't think I can do better than this. So what you need to have if you want to print the guide yourself. So there's a few things you need to get started. Number one is you need what we call an open software. And for example, 360 imaging, co-diagnostic, Blue Sky Bio, 3Shape. And some of these are associated with implant companies, some of these are not, some of these are free, some of these you have to pay for. But you just have to think about what kind of revenue and what kind of program software you want to use. You need the guided tube. And the important part is the guided tube is specific for the implant system, specific for the drill kit that you use, because you might not use the drill kit that you use for the implant system. It also specific for the software that you use to plan. So the guide tube is probably just as important to choice as other one because the cost of the guide tube is more than materials. For instance, if you print one guide full arch, you're probably going to spend maybe $4 for the material. But the guide tube is roughly about $10. So the guide tube is more expensive than materials. You need a printer and the resin. For example, the Form 2 and dental resin SG. You need to know what your printer like because you can't just use some resin that's not compatible with your printer. You need to train lab tech, assistant, or do it yourself, know your software and your hardware. All right, so when we start at VCU, we start to do a lot of this guided surgery, and I start to looking for things that we could do using the surgical guide. So one of the application, actually, we did use it for do sinus augmentation, and just run through the case for you, and then we probably could take a lunch break after this one. So this is actually the case that I work with Daniel, and we have a preoperative intraoral scan. You can use the scan of your CAS if you want. And you can see that the patient is missing the first molar on the left, which is number 26. Now, in theory, you could drill it and do osteotome sinus lift. For example, this is 8-millimeter implant that we're going to place. You can do osteotome sinus lift, and you can place 10-millimeter or longer implants. So we do diagnostic setup. This is the Blue Sky Bio software, and we print out the guide. But really, we're going to put the 10-millimeter implants. So what we did was we planned to put 8-millimeter, but actually we're going to put 10 millimeters. So we print the guide just like I showed you earlier. Now when the patient come in, put the guide in, and then you just basically drilled it to the 8-millimeter depth implant. So remember, you have like a tiny, tiny little layer of the bone underneath the implants. So without using osteotome, we just basically lift the sinus using the implants. So we put the implants in, and the implant pushed the sinus up for 3 more millimeters. And we also did, so you can see the green one here is the implant that we placed, and the gray one is the position that we plan. So we are pretty accurate based on our surgical planning. So again, the workflow would be you have the intraoral scan or scan the CAS, diagnostic setup, merge with the CBCT, place the implant. You can choose different length, but you will know exactly how deep your drill going to be. And in this case, you know accurate enough that you can actually lift the sinus just to place the implant. And this is actually on JPD. We also did an implant. You want to do lunch? Oh, well, yeah, we will have it this afternoon. You want to do this right now? Okay, I do one case and then we do lunch. Because we can, she wanted to talk about the trephine drill. So we can actually, I didn't come up with the, they have the idea of the trephination guided surgery separate than we have. So at about the same time we place that implant, I have a patient who I reconstruct him with the 8 implant in the maxilla. And the patient actually worked as a standardizer for college basketball hoops. So he will go around and standardize all this. He have a great job. He got to go to all these different colleges. One day while he used the wrench to fix the hoops, he slipped and dropped the wrench and hit his mouth. And it broke off two of the implants, and the screw stuck in there like cold welded, so we couldn't get it out. So when he actually drove from North Carolina to see me in Virginia, and what happened was I have these 2 old Astrotech implant with a tiny little screw cold welded into the implants. So there's no way I can re-thread this screw. So what we planned was we could drill this implant out. Now the option would be I just can open flap and I slowly grind it out or untorque the implants out. The issue would be that he doesn't have a lot of bone, and we want to kind of try to do most conservative possible. We also want to put the implant at the same time because you have to drive from North Carolina 4 hours. So what we did was we pretend that we're going to put a larger implant in there, But this size of large implant is the same size as the trap-fry drill. And we print out the guide that's fit with the trap-fry drill, and then we drill the implant out. We also plan another surgical kit to put the implant, just like you do immediate implant placement for natural teeth. We get the patient back, we put the guide in there, and without any flap, we can trap-fry the 2 implants out. And you don't actually have to trap-fry the whole thing. You just have to trap-fry the beginning halfway of the implant, and then you slowly unwind the implants out. And we place the 2 Zimmer implants after, and we actually published this also. It just came out. We did this case 2 years ago, but it just came out in JPD probably like 2 weeks ago. It's now on PubMed. So basically, you can use computer aid planning and trephination and using 3D printed guide. And you can see the advantage of trap-fry drill is because the trap-fry drill doesn't cut on the side, you can produce the guide without the surgical tube. And actually, that's what Dr. Nawakamon research is about. And we actually end up collaborated later. And we can actually have a trephination drill research. They actually got accepted in JPD like 5 days ago. Anyway, so let's do lunch, and we will come back and talk about cases that you can, how would you print your own guide.